In this video, we'll be looking at different foam rendering techniques using Arnold. To avoid the overhead of creating a brand new setup, we'll be working with the scene we had built in the previous video. If you're just tuning in and want to follow along, download the zip file in the description section of this video and extract it anywhere in your file system. Once you've extracted it, open the boatfoam.max scene. If you've chosen to download the file, you'll need to run the solver on your machine to see the liquid. To do that, select the liquid ocean object, then open the simulation view. Make sure the liquid, the foam, and the mesh generators are enabled, then press Solve. When the solver finishes, scrub the timeline to frame 28 and hit Render. You should see a foamy wake as the boat cuts through the water. In our current setup, the foam is being rendered in Arnold Point mode. Over in the material editor, we're using a white physical material to color the foam. We get a nice effect with these settings, but it's worth exploring different possibilities. If we're aiming for a bolder look, we can use the Arnold Surface mode. In this mode, we have two surface types to choose from. The implicit type is slow to render, but it's good at capturing high-frequency detail when your camera is close to the surface. For a faster alternative, we'll use the mesh surface type, which does a great job at this camera distance. We'll keep the same material for our foam, so we're all set to render. The result here looks like whipped cream, which could work for a creative project like a cartoon. On the other hand, if you're looking for a more realistic foam, a volume-based approach might work best. To render foam as a volume, we'll need to set the Render As option to Arnold Point. We'll keep driving the radius of each point based on the density channel, but since we're dealing with a volume, we'll need to increase the step size. The step size controls the ray marching process when the volume gets rendered. Small step sizes improve the sampling quality, but also increase the render time. We'll use a step size of 1 here for a good balance between render time and quality. Note that if we had left the step size at 0, we would ultimately end up with black ink in our water instead of foam. For the next step, we'll head over to the material editor. Under the Arnold Materials section, drag a standard volume into your view. Then, connect it to the liquid materials foam slot to replace the white physical material. Set the scattering color to white to drive the main color of your foam. Once you're done, hit Render. Now, clearly this gray foam doesn't exactly match up with the white color we had just set. To fix that, it might be tempting to brighten the volume's transparency color. However, the real solution actually lies in the render settings. In the Arnold Renderer tab, you'll notice that the volume indirect ray depth is set to 0 by default. This field controls the number of scattered ray bounces within the volume. At a value of 0, the volume sampling process is very limited. Instead, we'll increase it to 5 to bring out the color of our foam. The overall effect now looks much more convincing. Compared to the white physical material we were using earlier, the foam now dissipates more naturally and has a less grainy feel. Now, as a final point, because we've been rendering at 640 by 480, we've managed to get away with a relatively coarse simulation. At higher pixel resolutions, the human eye isn't as forgiving. Here, we can see that the splashing water looks less natural, and in later frames, the foam's white dots detract from the effect's realism. But despite these shortcomings, I'm not one to throw in the towel so easily. For the sake of completeness, and to validate the rendering techniques we've covered so far, I went through the process of simulating this scene at a master voxel size of 1. The simulation took close to 3 days on my 12-core workstation, and consumed close to 250 gigs of storage. I committed the same machine to render the whole frame sequence, which took about 2 days. With all that said and done, here's what it looks like. Now if you feel like trying this for yourself, you'll first need to replace the boat's collider with a solid mesh to represent the hull. This step is necessary since the boat's geometry causes unexpected voxelization patterns at lower voxel sizes, even if the solid robust conversion mode is enabled. The other major point touches on the water's meshing process. For the best result, I recommend you skip the mesh generation step in the solver and instead let Arnold create the mesh at render time. To do that, set the liquid's render as option to Arnold surface and use the mesh surface type. Finally, for the foam, use a density-controlled radius of 0.5 and apply the same volume rendering techniques we used in this video. I hope you found this foam rendering tutorial helpful, and thanks for watching.